Okay, so in this case, we've got FeS, right? So which is iron sulfide, iron 2 sulfide, but iron sulfide reacts with oxygen. And we've been asked to calculate the mass of Fe₂O₃ produced from the reaction, which, I mean, if you're familiar with oxidation numbers and whatnot, you know that this would be iron oxide. So specifically iron 3 oxide, right? And yeah, so we've been told that the limiting, well, not in those words, but we've been told that what is in excess is the oxygen, right? And based on that, we can basically infer that the limiting reagent in this reaction is actually the iron sulfide, right? And on that basis, we can, when we're looking at the iron oxide, we can reason that, well, we can use the mass of iron sulfide to kind of go through step by step to work out, leveraging the balance equation, what the mass of iron oxide is in this produced from this reaction. So let's go through the steps, shall we? So okay, so where I'm going to start with is simply, well, let's take a little bit of time to work slightly backwards from where the start of this is. So starting from the perspective of iron oxide, we know that the mass is going to be equal to the moles multiplied by the molar mass, right? Okay, so but we don't have the moles, but we can work out the molar mass from a periodic table. So let's focus on what is much more, maybe slightly more difficult to work out, or more tedious to work out from what we currently have in the information. So in terms of working out the moles, we're going to take our attention to the this information which we've been provided, which is about the iron sulfide, right? We've been told a mass, right? So we've got a mass, and in terms of the moles, in theory, the moles would be equal to the mass divided by the molar mass, right? So if we can work out the molar mass, then we can work out the moles because we've got the mass in the question, right? So this is what we're going to do. We're going to work out the molar mass of Fe₂S. I mean, not Fe₂S, FeS, right? Yeah, FeS. So the molar mass of FeS is equal to, right? So we've got iron here, which is 55.8. We've got sulfur here, which is 32.1, right? So if we work out the MR, it would simply be the relative atomic mass of the Fe plus the relative atomic mass of the sulfur, because each of them is just 1, right? So 55.8 plus 32.1, right? And that gives us 87.9, and that's going to be grams per mole, right? Now this we then use to work out the number of moles, right? So we've got the molar mass now. We've got the molar mass, right? So we can say we've got the molar mass, and we've also got the mass from the question, right? So let's now work out the moles using this information. So that's going to be equal, and I'm going to just specify here so it's clear later on. So the moles of specifically FeS, right? So we'll focus on is 30.5 divided by 87.9, 0.9, right? And that's going to be 30, 0. Well, it's going to be 0.34, right? 69852. So that's going to just be in moles, right? Moles. Okay, so as we discussed earlier on, the balance equation now has a very key role to play in helping us figure out the specific what we need to do with this. What we need to do with this to effectively work out the moles of Fe₂O₃, right? So let's actually go through that process. So effectively, when we look at Fe2S in the equation, the coefficient there is 4, right? I'm going to set up an equation here to make the comparison. So the moles of FeS, I'm going to compare that to the moles of Fe₂O₃, right? And this is going to be based on the coefficients. So the coefficient for Fe2S is, as you can see, is 4, right? And the coefficient for Fe₂O₃ is 2, right? What does this tell us? Well, what this tells us is that for every 4 moles of Fe2S, not Fe2S, for every 4 moles of FeS, we're going to have 2 moles of Fe₂O₃. And if we actually take out the factor of 2, just to kind of simplify things, that then becomes for every 2 moles of FeS, we're going to have 1 mole of Fe₂O₃. So on that basis, what do we need to do to figure out the moles of Fe₂O₃? Well, clearly we need to divide the moles of FeS by 2, right? So what we can say is that therefore the moles of Fe₂O₃ is equal to the moles of FeS divided by 2, right? Which is equal to, in this case, 0.3469825 divided by 2, right? And if we do that on a calculator, what do we get? I mean, you can either divide it by 2, multiply it by 0.5, the same thing, right? So, but if you work that out, what you get is 0.1734926, and that's going to be moles, right? So we now have the moles of Fe₂O₃, okay? And we've been asked, remember, we've been asked to calculate the mass, right? And if we refer back to this equation again, what did we discuss? We discussed that we had the molar mass already. So this, we have this number, right? Or at least we could work that out easily from the periodic table. And this was the one that was maybe a bit more tedious to work out. But now we have the moles as well. So at this stage, we simply need to plug these values into we need to multiply them basically. We've got the 2 values, and just multiply them to work out, well, what's the mass of the Fe₂O₃, right? Now, although I said it's straightforward to get the molar mass, we didn't actually calculate it. So we're going to do that now, all right? So MR of Fe₂O₃, that's going to be equal to 55.8 times 2 plus 16 times 3. Okay, so if you have a go at that and work out what that would give you, you should find that you get 159.6. okay, and that's going to be in grams per mole. Yeah, and so we have both of those values, which means that at this stage what we can do is just go through the process as we saw from the mass is equal to the moles times the molar mass. So therefore, in this case, the mass of Fe₂O₃ is equal to 159.6. So this is the MR, right? So the molar mass multiplied by this value, which we worked out to be the moles of the Fe₂O₃, right? So 0.1734926, right? So feel free to work that out and figure out what you get. And if you had a go at that, what you should have found is that gives you 27.6894120 grams. Okay, and if you round this is simply going to be well, why am I rounding it? Well, I'm rounding it just to be very clear on why I'm doing this step, right? I'm rounding it because the question asks me to, right? Give your answer to a maximum of 2 decimal places. So this is why I'm rounding it. But it's going to be 20. Oh no, let's use something else. It's going to be 27.6. And so if we round this up, it's going to be 69, right? So 69, and that's going to be that's a mass, so it's going to be in grams. In this case, so to 2 decimal places. Okay, so in this case, that is what our mass of Fe₂O₃ is going to be.